Yeah, hello, Adebayo. Hello, Adebayo, can you hear me?
Hi, Mr. J.
Yeah, all right. You can hear me loud and clear, right?
Yes, I can.
Okay. All right. So you've gone through your introduction and everything, right?
Yes.
Okay. All right, fine. Okay, so we'll just be on. I think I'm waiting for Victor. I can only see his video.
Yeah, I think it's connecting. Earlier.
What?
Victor is trying to connect.
Oh, okay. Okay.
Yeah.
All right. So this is your background. What is there a way you can put a STEAMLEDGE logo there?
Okay. Let me see if I have a STEAMLEDGE logo.
Possible. Victor can give you that.
Okay. I've just messaged him to send one, but let me also try to see if I can download one high resolution on the internet.
Okay.
Can you guys hear me?
Yes, I can hear you, Kumar.
Good. Thanks.
Yeah, right. So we have Victor and Adebayo. So Adebayo will be anchoring the webinar. Is going to log in back shortly. While Victor as well is going to also be leading us into the question and answer session. Yeah. So that's that. So I'll just be on the standby in case for other questions. So far we have 74 registered people.
Okay.
There's a possibility we have more, but we shall see.
Sounds good. How do I minimize this thing? Just getting the slide. Right. Perfect. So let me share my screen. Are you able to see the screen?
Yes, we can.
Okay.
We can. Right. Bayo, are you ready?
I'm ready, yeah. Did you ask me? By the way, do you think video is needed or video is not needed?
Okay. Yeah. So Bayo, please just proceed and let's start.
Ben, do you think I should turn on my video or video is not needed?
Yeah, you can turn on your video, please.
Oh, okay. Cool.
Yeah.
Cool.
Right. Adebayo, you can proceed and start.
Okay. Yeah, just let me know when everybody is ready. I can start. Yeah.
All right. Hello, world. Good morning, good afternoon, and good evening. Welcome to the STEAMLEDGE Career and Technology webinar. I'm your host, Adebayo, and I'm the head of Research Development and the Innovation Department here at STEAMLEDGE. I'm also joined here by my colleague, Victor Anawo. Victor, are you here?
Yes, hello. Hello, everybody. Good afternoon and welcome. My name is Victor from STEAMLEDGE. Thank you.
Awesome. This webinar will be discussing how we can ace coding interviews, system design interviews, and behavioral interviews on the international stage. So US-style interviews for the big tech companies. And also joining us here is our very esteemed guest, who's going to be sharing a presentation with us on this particular topic in the person of Mr. Kumar Chandan. Mr. Chandan, pleasure having you here with us.
Yes, yeah. Hey, Adebayo, and hey, Victor. Yeah, nice to meet you guys.
Awesome. Mr. Kumar is currently the senior software engineer at Walmart in the United States, where he has built MVPs and scaled them using AI and computer vision. He's also previously worked at Amazon, where he worked on the Amazon Alexa team as a software engineer. He's also worked at Oracle, where he helped build a project management system called Prime. He has also had recent offers from likes of Google, LinkedIn, TikTok, and the list goes on. And he somehow manages to balance all this together by still being an interviewer. He's a professional interviewer on interview.io, where he does mock interviews for candidates who want to apply for these big tech companies like Google, Facebook, LinkedIn.
Yeah, thank you for the intro. Should I get started? Hello.
Yes, you can
And
just.
the rest. So we're really excited to have his wonderful. I think Victor might have something to say to us concerning Q&As. We'll be having, I don't know if I'm audible, I'm having some internet connection error here, but we'll be having some Q&As at the end of this presentation. So if Victor can just come in and say something about that.
Okay, everybody, thank you very much. Welcome, Mr. Chandan and everybody. We'll be having questions and answers briefly after the whole presentation. And I'll just read out the rules for us about the questions. Okay, so you can ask your questions in the chat. You can drop your name, your school, or the company you're representing in your questions. Feel free to ask your questions. And your questions should be concise and straight to the point, okay? No anecdotes. And also, I'm going to read out the questions after the presentation so that our guest, Mr. Kumar Chandan, can help us answer. All right, over to you, Adebayo. Thank you very much.
Thank you so much, Victor. And so without wasting any more time, Mr. Kumar, the floor is yours.
Cool. Yeah, so let's get started. So like you mentioned, like I have done my bachelor's in electronics, master's in computer science. I've worked at Oracle, Amazon, and currently as an engineer within Walmart, Walmart's Intelligent Retail Lab, where we basically build like MVPs and try to scale them out. Other than that, I'm also a mock interviewer, and then I recently cleared interviews at Google, LinkedIn, TikTok, VMware, and so on. So yeah, like so why I think this will be useful for people is because in the beginning I got rejected by many companies when I was trying to get my first internship and full-time job here at, in the United States, and this will be useful for people mainly because like I thought like when we were doing my master's, like we did not have enough resources to prepare for these interviews. It was mainly just like going online and downloading like the cracking the code interview and just reading that book and not like practicing much, right? So it would have been great if somebody gave us shared their experience, how they cracked interviews at these big companies. Yeah, what helped them, what did not help them, right? So that kind of feedback would have helped us, helped me at least, and my friends to do better during our college days. And there were also like a lot of generous interviewers. Usually like, but it's there for most of them, but some companies do. So I've collected anecdotes or like examples from example feedbacks from theirs and included them in this presentation as well. And yeah, and because I'm also an interviewer, I have, I think, like good amount of exposure to how these candidates prepare, what their frequent mistakes are during these interviews, and how I help them to prepare for their dream job or anything they are doing, or anything with respect to interviews, right? So to get into today's agenda, we'll be discussing interview preparation strategy at high level, and then we'll be discussing resources for data structures. So DS, by the way, is data structures and algorithms. And then recommendations for like what to do during the coding round, suggestions, tips, and then how do you want to practice coding, like on a day-to-day or on a week-to-week basis, and then recommendations or suggestions for behavioral aspect of the interview. So usually in a coding round, at least in the United States, there's going to be 2 to 3 coding rounds, and then 1 to 2 system design interviews, and then at least 1 behavioral round, and maybe 1 like hiring manager rounds. And during behavioral rounds, they'll usually see your communication skills, technical communication skills, like what did you do in your past projects, how did you communicate with your team members, and what would you do in a hypothetical situation. So all those come under the umbrella of behavioral interviews. And then I have a checklist for system design interviews, like what kind of template you want to use when you're doing your system design interview, and resources to prepare for system design. So let me actually minimize this thing. Okay. Yeah, so for interview preparation, essentially, like you want to gather resources, right? Like before you begin anything, you want to know what resources you'll be using when you're and how you'll be like prepare a timeline, gather all the resources. Like if you attend an exam, you want to know like what books to read, and what or which teachers to contact, and all of that, right? So same thing with like tech interviews. You want to gather all the resources, like all the websites, all like lead code, websites like Pramp, all of these resources. I'll discuss them more in detail in the coming slides. And then you also want to find a mentor or a buddy if possible, ideally like somebody who is helping you during your preparation. So if somebody else is preparing for an interview, maybe tag team with them, see if you can help each other out, right? Like you can conduct mock interviews for them, they can conduct mock interviews for you, and that way you have a feedback loop. Or if you can find a mentor who you can pay, or they are willing to do it for free, then that is also a good scenario. And to choose a mentor, you want a mentor who is already good at what they are doing, right? So let's say like if you're going to want to apply for Amazon or Walmart or Google or wherever, so you want to find somebody who is already working there, or who is already at the same level in their life, so that they can mentor you. And then once you have these, you can prepare a plan, come up with a timeline, right? Like plan could be like setting milestones, weekly or bi-weekly assessments, and then you want to execute this plan day after day. So let's say like if you want to, if you have interviews coming up in a month, and you want to start now, and if you have not done this kind of prep already, then 1 month is kind of a short time. So try to schedule enough time to practice, and enough time to build your fundamentals, and that way you'll be in a much better shape. And this setting, you'll have many different areas you want to focus on, and in all those areas there'll be a lot of ground to cover, right? So that is the depth that we are talking about here. So let's say like if you pick system design, there are going to be many resources you can find online, like YouTube videos. You can find like Grokking the System Design Interview, which is a website where you can look at past questions. So let me show you like one select website, right? So system. So this is a good resource to get started for system design, right? So it tells you about like how to think about your system design interviews, what resources to use, and they also have like flashcard system as well. They also discuss algorithms, and then they have like general layout for which will apply to most of the systems, right? Most of the systems you see a lot of concepts to cover, right? So this is what I meant by depth, right? So when you start preparing for your system design, you have to learn all these things, and there won't be enough time to cover everything, right? So you want to focus on different areas at high level, and then drill down if you have more time into those areas. So let's say like if you pick CDNs, you can learn about, and then if you have enough time, you can drill down later. And same thing for load balancers. So you want to know about load balancers at high level, and then you want to drill down into like active, passive, active, and all of those different configurations for load balancers, right? So yeah, so always focus on breadth first, so that you know a little bit about everything, and then once you know a little bit about everything, go to that next level where you know a little bit more about it, and then so on. Similar to like the BFS DFS strategy, right? And then you want to be disciplined in your execution of the plan, right? So let's say like if you're too motivated one day, you do a lot of prep one day, but the next day you're not doing anything, right? Maybe you got tired, you are exhausted, you don't have that motivation, maybe something came up in your job, something came up in your school, you don't have enough time. So what I would say is like the mantra, right? Like slow and steady wins the race. So you want to keep progressing one by one on a daily basis. Let's say like if you do one lead code question one day, and then two lead code questions next day, at least, and even if you're making a day, overall that is going to pay off more than tons of motivation one day and not doing anything the other day. This works mainly because you want to keep your muscle memory, keep your focus, and keep your what do you say, yeah, you want to be in sync with your preparation, right? So even tiny amounts of progress, building that habit is usually doing anything on a certain day. So yeah, just like being disciplined, making at least some progress each day, if you have a interview coming up within 1 or 2 months or 3 months. What else? Yeah, so mastery through practice. So all of this, if you don't practice, then it will not like you'll not be in a good shape for these interviews. So obviously there's going to be a lot of coding practice, a lot of system design practice, where you are just like taking a system, talking through it end to end. Yeah, and we'll get into details of what that means. And then you also want to keep track of your progress from time to time, right? So you want to measure yourself tests. So let's say like if you pick like arrays, graphs, heaps, these are all different data structures. So you have a lot of resources where you can go and practice for free. So one of these is design interview, where you can learn about these, and the other website is tramp.com. So I don't know if you guys know about Tramp, but Tramp, you can easily, so let's say like you want to start a practice session. Let's say you want to do data structures and algorithms, right? So you'll choose this, and then you'll choose practice with peers or expert mock interview. Usually you want to do practice with peers here, and then you'll check next. I did all the questions here, so they don't have any question for me, but let's say like if you choose behavioral, you can click mock, and then you can pick your time, right? Whenever you are available. And usually yellow means somebody who is a great choice, but green is like the perfect match for your skill level, right? This is like the ideal pairing. And you can choose your skill level when you sign up. So you go here and you can yeah, here I think you can choose what your current level is. So you can choose whatever you're comfortable with and then go with that. So this is a really good website where you can get free feedback and you can practice under time constraint, right? Like where you'll have that simulated pressure of an actual interview. And once you do a lot of these, your actual interview, actual on-site loop is going to be more or less like a mock interview, right? Because you have done so many of these, the actual interview is going to be just like any other interview, and it'll get you over your anxiety or any fear you have of interviews. Yeah. And then yeah, I think that is it for this slide. So let's move on. Okay, so talking about resources for data structures and algorithms, right? So the like this wait, yeah. So this resource, like Coursera course by Robert Sedgwick, this is one of like the best courses I have me and my friends have found on the internet. Like if you want to build your fundamentals in algorithms and data structures, this is going to help you long term throughout your career, right? So let's say Robert Sedgwick, Coursera. Yeah, so this is the course. It's a free course. It's by Princeton University, and yeah, and it is one of the best courses. The instructors will go into union find, like the first data structure that they talk about. So this one is all about like dynamic connectivity problem. And then they'll talk about like how to analyze algorithms, like the time complexity, space complexity, how to think about those, stacks and queues, elementary sorts. So this will build your fundamentals, which you will be tested throughout during these interviews. So ideally, like before you do any lead code, before you do any kind of coding book or coding problems, you want to start here, build your fundamentals. And you can also, like, let's say like you finish stacks and queues, you can do a bunch of problems on stacks and queues here, or you can do it on lead code, right? You can choose the stacks and queues tag, you can practice a bunch of problems. So yeah, this one, so there's part one and part two. In part two, it's more about like strings, graphs. The first half of part two is really useful because all of that is more about like algorithms, and the second half is theoretical, and mostly you can skip it. But I would recommend like doing the first part and half of the second part. Yeah, so that is about this course. It's a free course, very good course. So the next one is choosing a book, right? Like you want to have some book which helps you to internalize patterns which are used in these kind of interviews. And for that, these two books are good, but I found there's one more book which I forgot to include in the slide, is this book. So it's a book and somebody has like pasted all the problems in GitHub, but this is going to be really useful because it tells you about all the different patterns which are usually asked in interview questions. So you'll have like 2-pointer pattern, slow and fast pointers, merging intervals. So any question related to like time intervals, right? So let's say like this question where you are given an array of intervals and find out if a person can attend all the appointments. So all these kind of questions you'll get used to if you know about these patterns beforehand. But let's say like if you don't know about these patterns and you go to the interview and you have to figure it out, it might be a hit or a miss, right? Because you'll have to think on the spot, think what kind of algorithm to use and everything. But if you have already practiced on these problems, you'll be in much better shape. And then there is going to be like 2 heaps, DFS, BFS, all of that, all those standard things. So yeah, this one is also like a good resource to go through. And then there is always like Lead Code, Geeks for Geeks. These websites will help you practice, like actually write out code and run it, see if it works, right? And then there is Interviewing.io for mock interviews. So here you can schedule mock interviews with actual people who are working in these companies, right? So you can go to like Interviewing.io, and you can like go here, and if you want to, let's say like get interviewed, you'll go here, and then you can, let's say like if you want professionals, if you want to do a one-on-one interview with a person who actually works at Google and has done interviews at Google, right? Who has conducted interviews with other people. So you can go ahead, similar to Pramp, you can choose your time, whatever works for you. But this one is not free like Pramp because you're actually talking to an actual interviewer who's getting paid. Yeah, so this one is paid resource. So what I would recommend is maybe do like 5 to 10 interviews on Pramp and then come to this thing, Interviewing.io, and see where you stand, right? To get actual interview rather than a peer. So that's where this will help. And you can also get like mentorship interviews. You can choose the area you want to be interviewed in. If you want to become an engineering manager, then you want to go for this kind of interview. Yeah, and as you can see, this is kind of expensive. So that's why like Prime will help, and maybe a couple of these interviews will help. Okay. So yeah, and then there are also like a lot of YouTube channels where you can go and look at recorded mock interview sessions, right? So you can go to YouTube, and let's say interviewing. So there is a channel for, yeah. So here, like the Interviewing.io also has free YouTube channel, right? So you can always look at what interviews were conducted in the past here. So you can go through all these interviews, get a sense of what actual interview looks like. So So let's say if you're interested in Netflix or interested in Google, Airbnb, you can choose questions here and go through them. And there are also like other channels, obviously. So there's Nick White, who's usually good. This guy, and he has a lot of playlists for. So here he has like hacker rank solutions, lead code solutions. So if any problem, let's say like if you're finding it hard to solve, so let's say you can type lead code rotten oranges, let's say, and usually you'll be able to find solutions for lead code problems here explained in detail. And if you have like lead code premium subscription, then you're also going to have those solutions in as part of lead code itself. But if you don't have lead code premium, then you can always come to YouTube or find solutions online as well. And usually these guys are pretty strong in discussing these solutions. Yeah. So we discussed PRAMP, and then there is also like if let's say you have a fear of dynamic programming, and you want to get over that fear, right? And anytime you have a fear of any data structure or any technique, you want to get over that, so you can go through like dynamic programming playlist. So there are a lot of those. So you can, this guy is pretty good. This guy Tushar Roy is pretty good. So he has lot of problems on that. You can go through like point change problem, longest bitonic sequence, knapsack, whatever, right? So all he has like I can. Once you do like, you'll be in good shape to solve most of dynamic programming problems. Yeah. And if you see like the underlying pattern is all about being exposed to these solving, right? So the more you're aware of these, the better. And then this one is a good paper on invariants. If you guys, I'll share how to write loops so that you can reason about those loops. Like when you're writing your loops, like what needs to stay consistent throughout the loops, like any invariants that needs to stay true, and how do you fix those invariants when you're looping over them. Obviously, like this paper will discuss it in more detail, and it will make more sense once you read it, but it's like a 20-30 minutes read, but this will be useful throughout your coding career and engineering career. And then there is also this book. This book is kind of lengthy book, so I would not recommend if you have like a deadline coming up for interviewing, but if you have a year or something, then definitely look into this book as well. But if you have less time, then just go with these resources. So coding do's and don'ts. So when you're given a problem for coding interviews, you don't want to straight away jump into solving the problem. Usually you want to ask clarifying questions and understand the question better, right? So let's say like somebody gave you an array problem, then you want to, let's say binary tree problem, right? Like go through all the binary tree and give me the longest path in the binary tree or something. It's like nodes in this binary tree is going to have, what are the values of this binary tree? Is it always going to be integers? Is it always going to be characters? And then you want to ask questions around, are there any special rules on this binary tree? Is it going to be a binary search tree, or is it just a general, could it be any possible binary tree? Is it balanced binary tree, right? So make sure to ask those questions before you even start thinking about how to solve. And your due diligence of asking questions, then check with the interviewer. Yeah, you also usually need to ask the interviewer if you want to check for like edge cases, right? Like, can the binary tree be empty? Can the binary single node? And in all these instances, what is the expected response, expected output? And then you want to think of an approach, right? So whenever you're given a problem, you want to think of an approach, how to do it. And when you're thinking of an approach, make sure to think of the approach, think out loud, right? Don't mumble, don't try to think out loud as much as possible, so that your interviewer knows what you're thinking and what your thought process is. A lot of candidates, they start thinking silently. So if you're going to do that, make sure to tell the interviewer that, hey, you are going to think silently for a few minutes, and then you'll discuss with them once you have a good understanding of what, how to solve the problem. And that is also totally okay. It's mostly about communication, right? Like you don't want to just start thinking silently without informing the interviewer, because all these interviews, they are going to figure out, like, to see if you are a good team player, if you're able to communicate technical ideas and how you think. So the better you keep your interviewer in sync with your thought process, keep them informed, what you're thinking, what you're not, the better it is for you. And then whenever you think of an approach, so let's say like you found a way to traverse the binary tree, you came up with an approach, right? So try to include the time and space complexity with the approach. Like be proactive about talking about time and space complexity. And whenever you do a coding problem, let's say on lead code or on ramp, always think about the time and space complexity. Even if there is no other interviewer, think about like what will be the time, what will be the space, because that will be asked to you even if you are not proactive about it, right? So why not be confident and tell them that this is going to be the time and space before they even ask you. The more independent, the more volunteer, like the more you volunteer to share out information, the better it is for you during these interviews. And then once you have discussed the approach, you have discussed the time and space complexity, then you can ask the interviewer if it is okay to begin coding, right? So let's say like you came up with an approach to discuss the time and space, and they say, hey, can you think of a better approach? So in that case, you'll have to go back, think of a better approach, discuss its time and space, and see if it is okay to proceed forward, right? Yeah, and usually like the first approach you think could be a brute force approach or a suboptimal approach, then you'll have to think harder, come up with a better approach, and convince the interviewer that that is going to be the most optimal approach. And then, yeah, don't be afraid to discuss a brute force approach, because like let's say let's say like they ask you to find what would be a good brute force problem. I can't think of any, but let's say like any problem you have to do brute force approach, right? So it is okay to discuss it, because usually brute force approach will lead you to a better solution once you start thinking about a brute force approach, right? So it's just a good idea to get started with a simple approach and then think about a optimal approach. And then what, like I said, like thinking out loud is one of the key signals interviewers look for. So be ready to think out loud. Don't be afraid. Yeah. Yeah. So like here, right? Like thinking. There's a quote here. So thinking is the hardest work there is. Probably why so few people engage in it. So yeah, the better you are able to think on the spot, think under pressure, and thinking on the spot and thinking under pressure will only come if you have already been in that practice in the past when you're doing your practices, right? So always be ready to think harder, think deeper, take some time, write down your ideas on book, what you're thinking, and the clearly you can think, and the quicker you're able to evaluate ideas and reject ideas, the better you'll be during the actual interviews. Yeah, so let's move on. So yeah, so for coding do's and don'ts, yeah, try to communicate ideas at a higher level than code, English or pseudocode. So this means that when you're trying to talk to the interviewer, don't talk to them in terms of like for loops, this variable needs to be assigned to this and so and so. You want to talk more about at a strategy level, right? So like you'll traverse this BFS, traverse this binary tree in post-order traversal, pre-order traversal, and then you'll get answers from the children, and then you'll aggregate the answer at the current node, and then you'll return it, something like that, right? You don't want to talk code before you have talked strategy. So that is what this means. And yeah, so you want to do it this way because that is how you will communicate ideas in real life as well, right? Whenever you're trying to solve a problem, you don't straight away jump into code. You talk about things at a high level, and then you go and work on your bench on things at a lower level, at code level. That is what you want to demonstrate here as well. And then when you before you even begin to code, you make sure to plan your work before you code. So what does this mean? What this means is you want to note down all the high level strategies you discussed, maybe in pseudocode, maybe in English, right? And then convert that high level idea into code. Usually this will help if you are beginning to interview, right? If you're already, if you have already done like maybe like 20, 30 interviews, mock interviews or actual interviews, then you probably don't need this intermediate step. But if you're just getting started, this step will help you to make sure you're consistent with your approach, convert that to English and convert that to code. This will help you to go from high level to low level pretty quickly, so that you don't miss any steps and you're clear on what you're going to write before you even write the code. And feel free to ask any questions if anybody has questions. Yeah. Or if something doesn't make sense, feel free to ask. Yeah, and then during a lot of these interviews, there'll also be times when you're running low on time, right? And you want to think about it. Think about, let's say, usually during system design interviews, you'll not have enough time to cover all the different areas of the low level design. So you'll do a high level design. So let's say like during the high level design, you come up with a bunch of microservices which do specific things. And sometimes you'll not have enough time to drill deeper into like, why did you choose SQL database and not NoSQL database? Why did you do pull versus polling mechanism? Why did you use a database and not a message queue here, right? So all these things, if you don't have time, just note them down and you tell the interviewer that, hey, because you're running low on time, you'll focus on these things if you have time, and you can note them down and come back to it later. So that is what this means. Yeah, so this strategy will apply both for coding and system design. So for coding, it applies in the sense that sometimes you'll have a big function and you'll have helper functions, utility functions, which will do smaller things, right? Like reading the input or maybe sorting the input or something. So all these smaller functions, you don't have to worry about them too much, because those are simpler functions compared to the core idea which you're trying to write. And if you're low on time, just tell the interviewer that you'll declare the function and you'll come back and fill up the function if you have time later. Yeah. And then let's say like once you have written down the code, always make sure to eyeball the code before declaring it done, right? So you wrote the code for, let's say, like doing a yeah, like traversing the tree and collecting sum of all the nodes or something. So in that case, just make sure that there are no syntactical errors, no logical errors. Just maybe take a minute, look at the code. And then what you can also usually do is, like if you look at the next step, you want to do a walkthrough of this code, showing the state changes when you're doing the walkthrough, right? So you pick the code, you want to show them that how these variables change when you loop, iterate on the code, when you recurse on the code. So just like step through the code, don't step through the algorithm you have in your mind, right? So you don't want to, you may have an algorithm in mind, but the code might be something else. Code might have some bugs, right? So that's why you want to make sure that you're stepping through the code, not through the logic you have in mind. And when you're doing this walkthrough, usually you'll find out a couple of bugs, so fix them before you're given a chance to run it. And in lot of these interviews, at least in the US ones, they'll not give you a chance to even run the code. They'll just ask you to convince them that the code is going to run the code. You just have to walk through the code and show them that this code is going to work and it is going to do the thing it is expected to do. So in all these cases, like being able to walk through the code quickly, showing them the state changes and showing them that it is getting you the expected output is a good skill. And try to step through the, if you are in practice of walking through the code, you should be able to do it in a couple of minutes to 3 to 4 minutes, right? Yeah. And ideally you want to benchmark yourself doing these coding interviews within 20 to 30 minutes per problem, right? For lead code medium questions, lead code medium is a medium difficulty question, right? So you want to do these questions within 20 to 30 minutes so that you have enough time to do the follow-up question or enough time to do the second question. Facebook usually will ask you like 2 questions within 45 minutes. Google will ask you like one question followed by a couple of follow-up questions. So that's why it's good to time yourself, make sure you're able to meet the time constraint of 20 to 30 minutes per problem. And then once you write the code, let's say you wrote the code, you did the eyeballing of the code to make sure it looks good, you did the walkthrough, then what you want to do is you want to discuss test cases with the interviewer, right? What are the different test cases you'll test your solution with? So let's say like if you pick the binary tree example, you want to tell them that, hey, you want to test your solution with an empty tree where you're not given the root of the node is empty. And then you want to test with a single node tree. You want to test with maybe a balanced complete tree. You want to test with tree which looks like a linked list. You want to test it with a big tree, right? So for all these cases, you don't necessarily have to write code to test it, but you discuss it with them, because usually you won't have enough time to write code to test everything. So just bringing up the discussion shows that you care about testing and you know what kind of tests to write. And then a few more do's and don'ts. We already discussed this. Try to finish the problem in 20 to 30 minutes. And for this, like Tramp will help. And whenever you're doing your lead code, maintain like a alarm or something, like, so that you're able to do your thinking, do your thinking about time and space, do your thinking about test cases, writing the code, everything within 30 minutes. And then be open to hints from the interviewer. They want you to succeed. So what this means is that sometimes good interviewers will give you subtle hints, and if you are able to take those hints and expand on that approach, it is only going to be good for you. Some interviewees can tend to like skip those hints, right? Like let's say like you're too focused on your approach, and sometimes you may miss the hint that the interviewer gives you. So always be on the lookout for small hints which the interviewer is giving you in terms of constraints, in terms of approach you want to pick, right? So be open to that. And then if you know of like multiple approaches to solve a problem, then definitely discuss those. So like there could be a brute force approach to solve a problem. There could be a way to solve the problem using a sorting logic with n log n, but there might be a O of n solution as well, right? Where you don't even have to sort, where you can do a linear pass and extract whatever information you need. So yeah, be ready to discuss all of the time and space of each of those. And usually you want to avoid global variables, because global variables make the code hard to debug and manage the state, right? And if you have variables which are local to the scope of the function you wrote or the class you wrote, so in those cases it becomes easier to reason about the code. So definitely don't use global variables. It's usually frowned upon during these interviews. And then make sure that your function names are reasonable. And then if you have if you have the same piece of code used multiple times, try to put them into a function, reuse them. So like the standard reusing logic here. So this one is about like regarding preparing and practicing. So be ready to, let's see how much time we have. Okay. Yeah, so be ready to practice on paper or basic editor. Try to avoid IDEs. And you don't want to use like IDE like Eclipse or IntelliJ or anything, because you want to get good at spotting errors without any help from the coding environment, right? Usually you will not have any such support. So just practice on whiteboard or basic editor without any fancy syntax highlighting or anything. And be comfortable in the language of your choice. So let's say like if you are picking Python for interviews, so be ready to talk about be ready to use the libraries of Python whenever needed. Be ready with the syntax, like be comfortable with the syntax. Be comfortable in talking about, let's say like if Python uses tim sort for its sorting logic, then what will be the time and space for that? So be ready to discuss any underlying details of your language. Yeah, we talked about this using timer to simulate interview pressure. So yeah, and new algorithm, either like write it down on paper the next day so that you do that spaced repetition, right? You want to make sure that you still remember that algorithm or technique the next day. So write it down on paper, explain it to a friend or somebody. So do it for a couple of days and then you'll be good. And then be prepared to also like implement or at least know what happens in the underlying basic data structures, right? So that is where like this thing we discussed, like these courses will help. These will build your foundations. These courses will go and discuss how these algorithms are implemented under the hood, right? So how quicksort works, how priority queues works, how hash maps works. So all of those will be useful to build that fundamental. And then set up a recurring schedule to be disciplined about it. So set up a schedule for yourself so that you're making small improvements each day, each week, something like that. And then yeah, so we already talked about these, so I'll skip that. And this is also something which is useful during any interview, right? So let's say like if you are somebody who likes to think, pause and then make it clear to the interviewer at the beginning of the interview itself that you will be working quietly for a little bit, right? And once you have some idea of how to solve the problem, you'll share it with them. And if you have set up this kind of expectation in the beginning, then the interviewer will know what to expect, right? Because if the interviewer doesn't know what you're thinking, what you're doing, then they're more likely to say no to you for that round. But if you explain your thought process in the beginning, explain your expectations, that you usually spend a minute or two quietly thinking about the problem, and then you'll share your thoughts later, that tells the interviewer what to expect, right? So it is okay to set some kind of expectation, um, uh, to tell them that you're comfortable doing the process this way and that way. If both the party agrees, then that is good for both of you. And then behavioral questions, right? So for behavioral questions, you want to make sure you do some research about the company beforehand. So if you're going to a company X, make sure to just go to the website, see what their vision is, and just note down a few points, right? And then be ready to answer the question why you want a job at a company X. So always be prepared to talk about that for any company you go to. And then for behavioral questions, try to have a map of common scenarios and your experiences beforehand. So let's say like a common scenario is like they can ask you, tell me about a time when you had a conflict within your team and how did you handle the situation, right? So for that, like if you already have some scenario map to this kind of some example map to this kind of scenario, then you'll be able to quickly take that take that example and use it on the spot. So that's why like having this kind of map will help. Just go to the internet and find examples of behavioral questions for the role you're applying, and you'll find a lot of questions, and try to pick like usually like Amazon behavioral principles are really good. Like so tries to ask, they have leadership principles which covers a wide variety of principles, and then you can have examples for each of those principles. I think there are like 14 principles, and if you have answers for each of those principles, then you're already in a good shape to handle most of the behavioral questions. And you can look at like Amazon leadership principles. So yeah, like these are all the principles, like so you can read about the description and see if you had an instance in your career where you had to do so and so, right? Like some of these may not apply to you if you're not in a leadership position, but more or less you should be able to talk about these. And then follow the STAR technique for your responses. So STAR format is basically situation where you talk about like any question they ask you, try to fit the answer into a STAR format. And by that, what I mean is the S in the STAR stands for situation, where you explain your background, explain the context for the question asked, right? So you want to explain the context, saying that, hey, I was working on this project doing so and so, and that is when I had to do this task, right? So T is the task, what you actually had to do when you were doing, when, yeah, like whenever they ask you this question, you want to talk about the situation, the background, you want to talk about the task you had to do, you want to talk about the activity which you actually did, right? So to get the task done, what did you actually do? You talked to a bunch of people, you gathered a bunch of requirements, you sat down and developed the code, you tested it by using these frameworks, you deployed it in production, you got your metrics, right? So all of these things you want to talk about during the activity phase. And then R basically means the results, right? Like what results did you get when you had to do all of these things? So you can say something positive, or you can talk about a scenario when you learned something from this experience, or you can talk about like any impact you had following all these activities. And then avoid rambling, to be concise. So don't try to like include details which are not necessary for the question they asked you. Try to always keep it concise to the point when you're talking about these behavioral, when you're giving behavioral answers. And then, yeah, so we already talked about being concrete. Oh yeah, so provide concrete relevant examples, right? So whenever you're talking, giving an answer to a behavioral question, don't try to keep it very high level, so that you want to provide concrete details, because the more details you provide, the more convincing your answers become, right? So try to provide relevant details, relevant examples whenever possible, to show that you actually worked on the thing you are saying you worked on. And then, yeah, so for any big questions, so like sometimes they can ask you like a longer question, like a multi-part question. Tell me about a time where you had to do this and this. How did you do it? What your reaction was? How did you fix the problem, right? So something like this. If it is a multi-part question, try to note down the question in paper, and then try to answer all the pieces of the question asked one by one. Yeah. And then it's okay to think about a problem, about a question, a minute or two, so that you have enough time to organize your thoughts. So that is totally okay. Don't be in a rush. Try to speak as clearly as possible. And then have 3 to 4 questions ready for your interviewer, right? So usually you'll have like 3 to 4 general questions, and then ask maybe like a specific question for that company. So you can ask about like team size, you can ask about what tools they use, what technologies they use. You can ask about do they follow sprints, what their agile practices. You can ask about the product they're working on. You can ask about what is the day-to-day responsibility of the engineers who work on that team, right? So be prepared with some like common questions which you can ask any company, and then a couple of questions which are specific to that company. And then, yeah, obviously you can practice with interviewers about behavioral on PRAMP or interviewing IO for mock interviews. So let's jump quickly into, so there are like 3 more slides. Yeah. So system design checklist. You want to, whenever you're given a system design problem, let's say like if they ask you to design, let's say Facebook, design Instagram, design autocomplete search or anything, right? Design Google web crawler or whatever. So in all these questions, you want to gather requirements, right? You want to ask them how many users, who are the users. If they ask you like build Facebook, then you want to ask what is the daily active users. And then you can ask things around like how many friends each user is going to have on average, right? And you can also make educated guesses, like let's say like each friend has 100 friend, each user has 100 friends on average, right? So you can make educated guesses and check with the interviewer if your assumptions are correct. So that is all of this, you'll do that during the requirements gathering phase. And then you want to jump into estimations. Actually, before even estimations, you want to talk about, there's also one more thing here, non-functional requirements, right? So non-functional requirements are the requirements which are important to the system besides the given functional requirements, right? So functional requirements could be build a Google web crawler which crawls the entire web page, web, and builds an index so that you can search against it. non-functional requirement will be something like it should have low latency. It should be able to build an index without having to recursively go in loops, something like that, right? It should be able to store like durability aspect of this index. So anything which is useful in terms of maintaining the system to keep it running, right? You want to talk about during non-functional requirements. And there is also like usually the consistency versus availability argument here as well. So you also want to talk about that. Like how available is your system going to be? So all of that you can look here. All of that will be discussed here. Availability and yeah, so availability versus consistency, right? So maybe read about this and it will make more sense of what to discuss here. And then you want to jump into estimations of what is going to be your required bandwidth to maintain the system, what is going to be the request per second you're expecting, what is going to be the storage requirements. So all of that you'll be doing some math here to show that you can do you can do these math, and you can call out anything which looks like an outlier. Like let's say, like if you're seeing that the system is going to consume a lot of bandwidth, then make a note of it here, and then you'll have to go into your high level design and figure out what you can do in your high level or low level design to meet that requirement or estimation which you already did. And then during high level design, you want to talk about you want to come up with high level pieces of the system which will meet your functional requirements which you gather here. So you want to show them that, hey, you will need these high level blocks to finish to meet the goals of your system. And then once you're done with that, and usually you'll do some like drawing there to show how the data flows and how your service will accomplish the goal which it said it would. And during scaling aspect, you want to talk about like if you're building your service very modular in like the modern microservices way, then you should be easily be able to scale it by adding more, by doing horizontal scaling on those individual components. So be ready to talk about that, and be ready to identify any like bottlenecks, any single point of failures for your system, right? So if you are again, like the volunteering aspect, the proactive aspect comes here as well. Like if you are the person who is going ahead and pointing out that these are the failures I can see in my system, and you can talk about how you can improve or fix these failures, then you'll be in a much better place, right? So be proactive about this, and then be ready to answer questions about fault tolerance, right? So what happens if a certain service crashes? How will you come back, rehydrate its state? If it is a stateful service, how will you hydrate its state? If it is a stateless service, you don't have to worry usually. But yeah, so be ready to talk. If a service is maintaining some state, then be ready to talk about what happens if it fails. How do you reconcile from that? And then usually you want to you also want to be familiar in the areas of like replication for data, sharding your databases, partitioning your databases, indexing them. So and for indexing, look into like B plus tree and then LSM tree, like bunch of trees, right? Whatever tree which you're going to use. I think LSM will be used for storage, but B plus tree will be useful for indexing. And then also be prepared to talk about monitoring, like how do you monitor your system, like what metrics do you, application level metrics you emit, how do you collect those metrics, how do you index them, how do you search those metrics, how do you create alarms on top of those metrics so that you're able to monitor your system, provide on-call support and all of that. And then this one is about like, is your system easily extendable to new use cases? So this one is more about like the open closed principle, where you want to keep your system open for extension but closed for modification. And you can read about that. Yeah, that's like a general architecture design choice. So coming into resources for system design. So I already talked about the system design primer repo. So this is the repo. Very useful repo. It is very detailed and comprehensive. If you just read this alone, this should be sufficient for most of your system design needs. But usually you also want to look at other interview, like there's also this one, Rocking the System Design interview. This one is a paid website. This one is similar. The first one is similar to this. So you don't necessarily have to buy this, but definitely like get this book. This book is really useful because it talks about distributed systems and problems, common patterns of problems and their solutions in distributed systems. This will be useful like throughout your long-term career. So highly recommended. And then there are a lot of YouTube channels where you can go for system design resources. Like Gaurav Sain is a good YouTube channel, Success in Tech, Tech Dummies. All of these will take a system and discuss that system in detail. And you want to know how the system works, on usually without having to read a lot of articles. If you are into reading articles, then that obviously will work. But if you are not into reading a lot of articles, then you can just go through these channels and they'll help you. And again, you can always use these resources. Yeah, that is all from me. Yeah, I can stop here.
Okay, thank you very much, Mr. Kumar Chandan, for this
Yeah,
wonderful one you've done for us. Okay, all right. So we have some questions here that have been asked. I'm going to read them out to you. Our first question is: can you give more insight into in-demand skill sets for undergraduates and early career starters should focus on?
Can you repeat the question again? In-demand skills and what?
Yes, can you give more insight into in-demand skill sets that undergraduate students and early career starters should focus on?
Oh, in-demand skills for people who are still in college?
Yes, exactly.
Okay. I mean, so whatever they are interested in, right? Like the first thing is whatever you are in that particular student is interested in, they should go for that, and then they should find how they can use that skill in that area. And let's say like if they are interested in painting, then it won't help them to go into like computer science, right? So first they should see if they want to apply for technical jobs like in computer science, then they should see if they are willing to work through all these problems, right? If that is something which appeals to them. But other than that, like usually like Google will help you, right? Like what are what are the trending, if you want to figure out trending jobs in architecture, let's say, right? So usually Google will tell you what the current trend is. So you can go here and even right here, right? So like jobs near me. So you can look at like what are the jobs that people are applying to, which are trending near you. And if you usually look at the jobs board, you'll get a good sense of like what is out there in this architecture area, right? So you'll see like information architecture manager, application architect, and so on and so forth. If you are interested in like applying for jobs, but if you are interested in like building your own like business or something, then obviously that is something else, and you'll have to go and work with like-minded people who are starting their own businesses and stuff. So it, yeah, like you usually like just Googling will help, I think, unless you are already focused in a specific field, then you just have to find more resources and work on it. Yeah, and does that answer the question or no? Not really.
Oh, I believe so. Thank you very much for that. We have another question here, which is how are these three interviews typically weighted by the employer? Thus, the three interviews are coding, system design, behavioral. How are they weighted? Is it equally or otherwise?
Is it equal? The three interviews, what about them?
Yeah, coding, system designs, and behavioral. Well, which one is more preference? How are they weighted?
Oh, okay. How are they weighted? Okay.
Yes.
So I would say like for like the most important one, system design and the most important one is coding, right? And then the second weight is system design, and system design is more important in the sense that it will tell the interviewer which level to give you, right? Like to give you senior level, staff level, mid level, junior level. So all of that will be decided by system design, and coding is like the core, because that'll give them a base level signal that this guy can at least work on coding can write code, right? So that is the base level assessment that anybody should know when they are applying for these jobs. And system design is mainly to see your seniority, to gauge your seniority. You understand designing, you understand about designing systems. And then behavioral is not really that important. Behavioral, more or less, they're looking for if you have actually if you actually have the experience you're talking about and you're able to communicate with people, right? So there, with behavioral, what they're trying to look at is, are you a bad communicator or are you a good technical communicator, right? If you are a good communicator, they'll take you out. They'll not let you go into further rounds. But if you are good, then they'll give you an offer, right? But that is the only thing with behavioral interviews. Whereas with coding rounds, even if you fail, like,
okay, thank you very much.
Oh yeah, okay, cool.
Oh, sorry about that. You done? Yeah. All right. So thank you very much. There's another question here, which is, in attaching time and space complexity, does this mean discussing these with the interviewer during communication, or including these as a comment in your programming solution? Please discussing these with the interviewer during communication, or including these as a programming solution.
Yeah. Not just as a comment, but discussing them.
Okay, thank you very much. And we have two more questions. This one is, does this interview, what's the time frame of these interviews? Does it last a few hours, or can it run into days? And also, is there a difference in the way the interview is conducted online and offline?
So there is, to answer the first question, it is for, usually these interviews are 1 hour each, 45 minutes to 1 hour each, depending on the company. And you'll have at least 4 to 5 rounds, or sometimes 6 to 7 rounds, right, depending on the company. But usually it's between 4 to 7 rounds, based on the company. So like if there are, let's say like 6 of them is going to be the first technical phone screen, and then after that, if you get qualified, then invite you for the on-site loop. And on-site loop is going to be 2 to 3 coding rounds, and then after 3 coding rounds, you'll have 1 to 2 system design rounds, and after that 1 to 2 behavioral rounds, right? So so that's why that range of 4 to 7.
Okay. Well, thank you very much. It's really a short interview. Well, we have this last question, which is made up.
Yeah, it can be made up, but as long as you're able to provide concrete examples for them.
All right. Thank you very much, Chandan. We appreciate you with this lecture. Thank you, everybody. I hope we all learned a lot. Okay, and we're just going to to talk more about STEAMLEDGE now, a little while we round off our session. Well, we have some programs coming up from STEAMLEDGE, which is STEAMPAL. STEAMPAL is a program which will be coming up soon, and we'll be beginning. It's a coding program where you learn how to code. It's like we're creating an environment for technology, if you're enthusiastic about learning many of these skills, so that you can be eligible for these interviews. Well, you can come up to the STEAMLEDGE and you can just contact us. Then we have our next seminar. Our next webinar is coming up soon. It's going to be a series, and it's on artificial intelligence. So the next topic is the AI revolution, hype or hope. So that's just that this AI revolution, this artificial intelligence that is becoming rampant in the whole world now, is it just hype, or are we actually hoping towards it? Is it something that is actually real? Is it something that is actually happening? Or is it just basically just hype? Well, please make sure you attend this next seminar. You can see how insightful this has been. But we appreciate our guests for his wonderful time he has spent with us here. And we also appreciate every one of us attending this here. All right, so please make sure you attend this. Our next one will be communicated to us via our emails. We already have our emails, so we'll communicate it to them. All right, thank you, everybody. And Mr. Adebayo, would you like to say something before we close?
Thank you so much, Victor. Yeah, thank you so much, Mr. Kumar. We really learned a lot.
Oh yeah, thank you, Adebayo, and thank you, Victor. Yeah.
Awesome. So good night, everyone. A good day, everyone.
All right, thank you. Please, everybody, have a great day. I'll see you in our next webinar.